Hello everyone, myself Ganga Rawat, working as an assistant professor in RPIIT Medical and Technical Campus. My topic for today is electrolysis. Earlier we discussed about what electrolysis is and a slight discussion about what is an electrolytic cell. It's a cell. So, as you can see, I have drawn a simple diagram of an electrolytic cell, but we will be discussing it with the help of an example, that is with the help of a process called electrolytic refining, which is one of the applications of this electrolysis process. So, electrolytic refining, I can explain it to you like this: electrolytic refining. So, basically, what electrolytic refining is, when you refine something, when you get a pure outcome of an impure result, that process is called electrolytic refining, or it is, in other words, it is the purification of metal is also known as electrolytic refining, but when it is in terms of electrolysis, it is called electrolytic refining. Now, taking an example of the copper sulfate solution, it's the copper sulfate solution which gets dissociated in the form of copper plus 2 ions and sulfate ions. So basically, as an electrolyte, what we are taking over here as an electrolyte is copper sulfate solution. Now, why do we require an electrolyte? Because it provides the medium to the ions for the free movement, so that the electricity can pass, or the movement of electrons or the ions, they could move easily. So followed by, this will work as the cathode. So cathode is something, an electrode which is connected to the negative terminal of the battery, whereas this will work as the anode. So normally what happens is, whenever we take the anode, it is basically the substance to be refined, means the impure, over here we will take the impure copper as anode, whereas in the pure form, in this cathode, we will take the pure copper. Now, what will happen in this particular electrolyte is, from this in this particular electrolyte, what will happen? The conjugate, means this copper sulfate, it will get dissociated. It will form ions in the form of copper and sulfate ions. So, what will happen here? We have got copper ions and sulfate ions both. So, what will happen? Like electrons, they start moving from this direction, like this, they move from positive terminal to the negative terminal. So from here we have got electrons as well. So when this copper ions, they are free over here, they move towards the cathode, and on gaining 2 electrons, they will combine over here. They will stick to this portion which is the cathode. So at cathode, what happens is, copper 2 plus, on gaining 2 electrons, it combines to form copper. That is, over here, the reduction process takes place. Why the reduction process? Because here the oxidation state is changing from +2 to its 0 state. Means the oxidation state over here, it is changing from +2, its +2 oxidation state to the 0 oxidation state. Whereas, just to stabilize the number of ions over here in the electrolyte, what will happen? This anode will release out the copper ions. So over here at anode, let's say we write over here at anode, what will happen is, the copper will release the copper plus 2 ions and the 2 electrons. Where the 2 electrons, the movement of electrons will start like this. They move upward. They will move in the upward direction. Whereas on coming from here, the movement of electrons becomes downward. So from here, it will release the copper 2 plus ions, and the electrons will start moving. So overall, what happens is, these copper ions are taken by the cathode, whereas this anode releases 2 plus ions in the electrolyte. So the overall number of ions of the overall number of copper ions remains stagnant, means stable. And what happens is, as this copper ions like this, so this process is called the oxidation, means the oxidation process takes place. where at the anode. Why oxidation state? Why oxidation process? Because over here the oxidation state is changing from 0 oxidation state to its +2 oxidation state. Now what happens is, because it is giving out 2 copper plus ions, so the size will decrease and it will become thin. Like thinning of this electrode will take place. Whereas in contradiction to the anode, the thickening of this cathode layer will take place. Now what happens is, there are impurities present over here. So for copper, the impurities can be silver and gold. Like in metallurgy processes, we also know that metals, they combine with the other metals. So the other metals at that time, they act as the impurities. So what happens is, the other impurities, they just settle down over here. So we have got impurities over here which settles down at the bottom, and the pure copper, it gets accumulated at the cathode, whereas the decrease in the layer of anode starts, and as a result what happens is, we get Ag or silver or gold over here at the bottom as impurities, and the copper ions, they get stabilized, the number of copper ions in the electrolyte. Whereas if the copper ions are having impurities as zinc or magnesium, which are more reactive than the copper, what will happen? The zinc ions will move here and they get accumulated in the electrolyte. Therefore, there will be a need of changing the particular electrolyte after some time. So, the overall process of electro refining, which is the purification of the copper, kind of copper, here the copper metal or the metals, takes place by the process of electrolysis, is called electro refining. I hope one of the applications of electrolysis, that is the electrolytic refining, is much more clear to you. And if you got any of the doubt, please do write them below in the comment box. Thank you.